Hello everyone, I am Aparna. I am a civil engineering graduate and I graduated in the middle of the pandemic. So, the last few months gave me a lot of time to explore new tools and softwares in structural design, architectural design, planning, and scheduling. So, I've done a small project on generative design using Refinery. Refinery is a generative design tool used in Dynamo, and Dynamo is a visual programming tool that can be used for Revit. This project is a basic application of generative design. I've taken a plot area and I need to construct a building in this plot. I want to make an informed decision of the dimensions of the building, such as height, width, and length of the building. So I want to look at different permutations and combinations of these dimensions and make my decision based on the costs incurred in construction and the rentable floor area that I can obtain after construction. So Refinery helps you by giving a number of design solutions by optimizing costs and floor area, and it gives you some of the most feasible solutions to pick from. So let's have a look at the project.
So here we're opening a new Revit project. The last time I used my Dynamo code and ran the Dynamo code, this was what had come on my Revit project. So even if you start a new one, it's okay. So I'm going to manage. I'm going to Dynamo. Yes. So I'm opening the project that I had already made on Dynamo. So let's open that. So yeah, this is a very simple Dynamo code. And I've explained in the intro a brief about the project. So basically, we are looking for a building design with variable height, length, and width, which has a large floor area for a comparatively minimum cost. Like we want to see the comparison and pick whichever solution is good for us. So when we enter our outputs and our functions into Refinery, it's going to give us a number of solutions, design solutions that we can pick from. Whichever is suitable, we can just pick it. So I have a description, a brief description of the project over here, and I also have the color coding of the project here. So the inputs are in pink, the functions in green, and the outputs in orange. And how to define inputs is we go to a node, we right click, and we define that it's an input or if it's an output. And functions are just basic, like you don't have to define them. They will run as long as they have an input and they give an output to some other node. So these are nodes. These are input nodes, these are function nodes, and these are output nodes. So these are my input nodes. I have three variables in my project, which is the height of the building, the width and the length, and I have taken all the values in mm. And this type of input is called the number slider. There are other inputs that you will find in the node library. So this is how you go to the node library. So this is a basic inputs. You can also have number, where you just type in the number and give your constraints on Refinery. But I have used number slider because it's just easier, and number sliders have this option where you can give your minimum, maximum, and increment steps in the input node itself. So it just makes life a little easier. And my height of the building is basically levels, floor levels. So I wanted a floor level of 3.75 meters. So I have put a step over here. And even for width and length, I have some ranges and step. If you notice, this part of the code is all connected together and this part on my bottom left is not. So the reason is I wanted my building to be within a boundary, but I didn't put this boundary as a constraint to my building design. I just defined the boundary for visual purposes. So there are multiple ways of making a boundary. You can make it on Revit, and you can select the boundary on Dynamo, and use it as your constraint for your building design. But here I've just made it on Dynamo for visual purposes. You can also use this boundary surface as a constraint for your building design directly within Dynamo. But that's a slightly different process, and I will probably do it on another project on another day. So here I have given the coordinate points manually, and there are two processes here. One, I have made a surface with colors and everything of the boundary of the whole area. So this is only for visual purposes, and I've also made a boundary wall, and this is the wall that is reflecting on my Revit project. So how to make this? First, I give the points. I make coordinates out of those points, and I make a list of these points and use them as my perimeter points for my surface. So all of these nodes are available by default on Dynamo, and they will guide you as to what to do. Like, you can just hover over them and it'll give you a description and what inputs it needs. So yeah, and this is basically to color the uh, surface. And how to make a wall. So this is the actual node that I've used to make a wall. So this wall node needs a curve. So I've made a curve of the boundary. And how I made it is I made a rectangle of using these four coordinates. And this is a very important node in Dynamo. A lot of times we don't understand the use of this, but this is very useful. May not look like that, but this will help you change any kind of geometry into a curve. So yes, so we have a curve and we need a level. So a wall needs a base constraint level uh, and a top constraint. So we are defining these levels. You can just use the level node, pick your level and give it to this node. And I did not make another level for the top constraint of the wall. I just made an offset level and of 1 meter height and given it to this wall node. And there is a default node which helps you pick wall types that are available in your Revit families. So I've just given that wall type to this wall, and this wall node does not necessarily have to um, connect to another node. It will, when we run this code, it will automatically execute the wall, and you can see it on your Revit file. So and also in these nodes, in all of these nodes, when you hover, it will also give you the output at the bottom. So right now we've not run the code, and that is why you can't see the output. When we run the code, we'll be able to see the output. And other than the outer boundary, I've also made an inner boundary. So I want my building to be within the outer boundary, and I want it to leave 3 meters on three sides and 10 meters on one side. So again, I've not used this as a constraint in my building design. I've just um, made these boundaries for visual purposes. So yeah, this is my building boundary, and I've given it different colors, and I just need to connect this surface here to this geometry node and it'll execute. So even this I've entered manually, and it's pretty similar to what you can see here in outer boundary. So here I've run the code, and you can see a blue boundary and a yellow boundary. The blue boundary is the outer boundary that I have defined here, and the building boundary is the yellow surface. So yeah, and this cuboid is basically the building that is defined here. So if you have automatic run on, then you can just sort of play around with this. Change according, like your height, your width, your length. These are the different permutations and combinations of height, width, and length that Refinery is going to play with to give you a good design solution. So now let's have a look at how to make the building geometry. So the building geometry is basically a cuboid. So we're using this cuboid node to make it, and it needs an origin and it needs width, length, and height. So we've taken width, length, and height from our inputs here, and we've given it the origin, which is 0, 0, 0, and these are the default values for this point coordinate. And this is how this cuboid is made. So since cuboid is already a geometry, we can visualize it directly over here. So these are the nodes that are used for visualization on Dynamo. So, but the problem is that this cuboid gets made on both sides of the origin. So what I mean by that, I will show. So if I connect this cuboid directly to this visualization node, so it'll get created this way. So yeah, it'll get created on both sides of the origin. The height will be the same, but it'll just get visualized like this. So to avoid that, so we're going to translate this reference point using geometry.translate node, and yes, and this is the translated geometry is what we're going to give to this node, and we're going to translate it to half the height because we want it above the boundary. So once all of this visualization is done, let's go to the main part of this project, which is the cost estimation and total floor area and how we got to these outputs. So let's get to the main part of this project, which is getting the cost estimation and the total floor area. So for this cost estimation, I need some data like the length, breadth, and width of the building, the column layout, the length of the beams, the area of the slabs, and how many footings are there, etc. And for total floor area also, I will need some of these data. So first I am going to consolidate this data required for both of these components, and I'm gonna calculate them in a different code block, which I have named as column layout. So this is a code block, and in this code block we can write our code in Python, and we can have any number of inputs, and we can rename the code block however we want. So let's have a look at this code block. So yeah, here we have a little very simple Python code. So the code is just this much. What I have selected, only this is the code that I have written. The rest of it is already given by default. And these are just parts of the syntax and importing packages and such. So ignore that for now. Let's have a look at this code. So IN is basically the list of input values. So a list, the components of a list are accessed by using square brackets and numbers from 0, 1, and 2, like numbers from 0. So this is called indexing, writing these numbers from 0. So this IN list has 3 values because I have 3 inputs here. So the first one, yeah, the first input is basically the height, and the second one is the width, and the third one is the length. So I've taken the height and I've divided it by the floor height that I have so that I can get the number of stories that I have in this project. And I've also taken the input values of length and width into these variables L and B. And I have taken another variable and given it the value for meters. And this variable is basically the distance between the columns. So this is something that I have taken just for this example project. So it'll depend on your structural design, but this is just an assumption that I'm taking. And I've also given conditions that if the floor levels are more, then the distance between the columns should reduce. So just so that my estimation is a little um, more for buildings with more number of floors. These are all the input values for my column layout. So how to find my number of columns is I've given a random variable name ln. So this is basically the number of columns along the length of my building. So I've taken a math function called ceil. So ceil is something that helps you give the higher number. Like if you have a number like 2.65, so this this gives the ceiling value, which is 3. So it gives the next whole number. So that is what I have used so that I can get the next whole number when I'm calculating my number of columns. So I've calculated the number of columns along the length and I also along the breadth. And this way I got the total number of columns. And all of this data, like the number of floors, the length, the breadth, and the number of columns, and the number of columns along length and breadth, everything that I have calculated over here in this code, I have entered into a different list so that I can access all of this data in the nodes that I connect this node to. So let's see how that happens. So out equal to n is basically the output. I'm outputting this whole list of data. So from this node, it is going to both of these nodes, cost estimation and total floor area. So let's have a look at total floor area first, and this output we're giving as an input for this code block that I've made for floor area. So yeah, so here the input, there's only one input and this input is a list. So this since it's a single input and it's the first one, it has to be accessed with the indexing 0. And since this is a list, the components of this list are accessed by using another indexing beside that. So here 0 is 6. So here n is basically the number of floors that we have. And similarly, I've used for length and breadth. And I've removed the wall area and I've calculated the floor area, rentable floor area of this project. Next is cost estimation. So let's have a look at this. So this is a little bit complicated because I calculated all the lens areas and volumes that I need within this same code and also gave the cost rates over here. So they can be divided and done, but I wanted to keep it simple, so I used a single code block for the whole calculation. So basically, we just use simple variables to calculate the lengths of beams, the areas of slab, and etc. And you get the input again from the same list from here. And I have taken a single input, which is the list. So for me, I feel like using lists is a little bit easier, but you can also have all of this data uh, in multiple inputs and take them from the input variables over here. But I just find this more consolidated and easier, so I'm doing it this way. So yes, here I have given my rates. I have got a total cost. I've only taken material costs. I have not considered any labor costs or anything. So whatever I've calculated, I've given it as an output. And yeah, and as I've mentioned before, we need to make sure that this is enabled in both of these. So, because that is how a refinery will know that these are the outputs and these need to be optimized, either maximized or minimized, or and it'll understand that these two are the parameters that are going to govern your design requirements. So let's export this project and create a study. So we'll export for generative design, export, yeah, and then we create a study. So yes, this is the refinery tool that we are going to use to generate our designs. So it has multiple methods and we're going to use optimize over here, and which inputs should vary. So you can keep some inputs as constants, but here we want all the inputs to vary. So we all of them should be selected, and which outputs should be used as goals. So both of them are our goals, and we want to minimize cost, but we want to maximize floor area. So we're going to click that. And which outputs should be constrained. So here, if you want to put a budget constraint for your cost, or you want to have a minimum floor area, you can have them here. So I'm just gonna write 100 here, and I'm gonna write maybe 30x here. But you can also avoid having these, and because you can access these values within the generated file, and I will show you how. So the population size generations and seeds are basically how many times it's gonna iterate and generate designs. So this you can keep it as this default or you can change it. So we can generate. So yes, once you generate the model, this is what you're gonna get. You're gonna get multiple solutions uh, of different dimensions of the building, and you'll get different cost estimations, floor areas, and there's multiple ways of visualizing this data. You can see it as a list here, or you can see it this way. And when you select a particular model here, you can see the details of the model on your right side, and you can have a look at an overall graph, and you can change the axis of the graph and have a look at the data. And this is another type of data, this, and this is actually very useful. I will show you why. So yes, when we were giving the constraints for our outputs, we had given 3 lakhs for cost estimation. So instead of doing that, we can do another thing. We can click on filter here, and we can filter which range of costs are we looking at. So we can select over here and then decide which one is most suitable for us. So within this group of models, you can see which one has maximum floor area and select it as your ideal design. So yes, if you have a constraint on height, you can have it on height, or if you have it on length, you can have it on length. So there are multiple ways of doing this. So it's not showing any solution here because there's nothing in common. So yeah, now there's something in common. So yeah, you can just basically play around with this and find which solution is best for you. This is a very basic project. There's a lot of things that you can actually do. You can explore a lot in this.